Number 3, let f be the continuous function defined on -4, 3, whose graph consisting of 3 line segments in a semicircle centered at the origin is given above. Let g be the function given by g of x is equal to the integral from 1 to x of f of t dt. Before I start this problem, because I know what type of problem we're heading into, I'm going to say that we're talking about g. It says that g is the integral, which I know is the area under the curve. So g is going to be the area under the curve. I know that g prime is actually just going to be f, which will be the curve. And I know that g double prime would be f prime, which would be the slopes. So that's going to help me as I work through it so that I don't have to do as much thinking in the middle of the problem. Right, first of all, part A says find the values of g of 2 and g of -2. So we're going to find g of 2. I'm just going to plug it right into that formula. It's going to go from 1 to 2 of f of t. And to get from 1 to 2, it's just going to, looks like it's just this little triangular area right there. And it's underneath the x-axis, so it's actually going to be a negative, so it's going to be 1/2 times the base. The base of that triangle is 1, and the height of that triangle, I might need to, I can't tell for sure. Well, I do know this is halfway in between 1 and 3, and if it's down at -1 at 3, it's just at probably 1/2 because it's halfway between, so it's going to be 1/2. So -1/2 times 1 times 1/2 will be -1/4. That would be worth 1 point. And then g of -2 is equal to the integral from 1 to -2 of f, which would actually be equal to the integral from -2 to 1. Don't forget we have to do that. And then when we do that, let's see, we're going to have -2, which is right there, till I get to 1. So it's going to be all of this portion right here. So I have a triangle and a half circle. I'm going to put that negative out front. This will be 1/2 times the base, which is 1, and then the height is 3. And then plus, well, actually I'm going to put minus because this is below the x-axis, and it's a half circle, so it will be 1/2 pi times the radius squared, and the radius of that circle is 1. So this will equal -1/2 times 1 times 3 is 3/2, and then this will be -1/2 pi, and since that negative is, I'm going to distribute it, I'll get -3/2 plus pi over 2. And if you wanted to go further than that, you could, but that is definitely far enough, and that would also be worth 1 point. Okay, part B. For each of g prime of -3 and g double prime of -3, find the value or state that it does not exist. Okay, g prime of -3, I know that that just equals f of -3, which means I'm just going to look at the curve. So at -3, that's my value right there. Woo. And once again, I notice it should just be halfway in between. So if this is at 3 and that was at 1, in between it should be at 2. So that will just be 2. That would be worth 1 point. And then g double prime of -3 would actually be the derivative of f, which is, I'm going to be looking at the slopes from what I put on my previous slide. So if I look at the slope at -3, I'll just need to find the slope of that line, and I'm going to use y2 minus y1 over x2 minus x1, so it'll be 3 minus 1 over -2 minus -4. That will give me 2 over 2, and that gives me 1. So the slope of that is 1, and that is also worth 1 point. Okay, part C, find the x-coordinate of each point at which the graph of g has a horizontal tangent line. For each of these points, determine whether g has a relative minimum, relative maximum, or neither, a minimum nor a maximum at the point, and justify your answer. So I'm going to do just a couple of things here. We want to find the x-coordinate of each point, and then we need to determine, so that's the second thing we need to do, and I need to justify my answer. So pretty much 3 things going on in this problem. Okay, g has a horizontal tangent line. Well, if there's a horizontal tangent line, that would mean that g prime is equal to 0, and we already know that g prime is the same thing as f, it's just the curve. So I'm going to be looking on the curve for where it equals 0, and that's going to be at -1 and at 1. So horizontal tangent line at x equals -1 and x equals 1. So I found one answer, and so far that was worth, actually I kind of gave myself 2 points. Considering that g prime equals 0 is 1 point, and finding the horizontal tangent lines, that was worth another point. So notice the importance of just writing down what I'm going to do. I got a point for doing that. And then I have to decide whether those points are minimums, maximums, or neither. So I'm going to make myself a g prime chart. -1 and 1. Before -1, this graph is above the x-axis, so g prime will be positive. Between -1 and 1, it's negative, because it's below the x-axis, and after 1 it's also below the x-axis, so it's negative. So it does tell me for at each of those points, so at x equals -1, I will say that there is a relative max, and we definitely don't want to abbreviate when we're on the test actually, relative maximum, because g prime changes sign. Well, actually it doesn't just change sign, it changes from positive to negative. And then at x equals 1, I will say neither. And the reason that would be neither is because g prime does not change sign. And we do want to make sure that we do explain it. And we make sure that we read the directions so we get all the parts. And that actually, all that explanation was just worth 1 more point. Right, part D, for the interval between -4 and 3, find all values of x for which the graph of f has a point of inflection. So points of inflection we know have to deal with g double prime, so I'm going to make my g double prime chart. And g double prime I know is the slopes because it's equal to f prime. So if I look at the slopes are going up until I get to -2, and then the slopes are going down all the way till I get to 0, and then the slopes are positive till I get to 1, and then the slope is negative after I get to 1. Alright, so if I'm looking for points of inflection, wherever g double prime changes sign is where there'd be a point of inflection, so it would happen here, actually at all 3 of those points. So at x equals, I'm going to put point of inflection at x equals -2, x equals 0, and x equals 1, because g double prime changes sign. Okay, and this part of the problem was worth 1 for getting the right points of inflection, and then 1 for the explanation. So hopefully this was a pretty straightforward problem from you, and you did okay on it.